Today's video will demonstrate how to design a program using a UML class diagram. Hello, I'm James Helfrich. Of all the different design languages we have, flowcharts, pseudocode, structure charts, data flow diagrams, entity relationship diagrams, all these different tools, perhaps the most commonly used is the class diagram. This video will demonstrate how to use the class diagram to design a program that has many related classes. So for our first example, we're going to create a class diagram matching the following description. A financial chart is a graph consisting of a title, a chart legend, and the data of the chart. The data is a collection of individual transactions from a given account. So I'm going to start with a financial chart. So chart, I'm going to need a class for a chart because that's a noun. So I'm going to say a chart. And it's a graph. So it is a type of graph. Therefore, graph is going to be my base class and chart is going to be my derived class. It's going to consist of a title, a chart legend, and data. Those sound like attributes of my chart. So I'm going to make attributes, title, legend, and data. Now, the data is a collection of individual transactions. So the data type is going to be transactions. There's going to be many with a star. But now I need this new data type called a transaction. So I'm going to make a transaction that's associated with chart. And what's the association? Well, since the chart is going to refer to transaction but not create a transaction, it's going to be aggregation. And how many are there going to be? There's going to be many from a given account. So remember, the transaction is going to refer to an account. So therefore, there needs to be an account by association. And what's the association? It's aggregation as well, because a transaction is not going to create or destroy the account. It's just going to refer to the account, and there'll be exactly one. I'm also going to need a legend, and there's going to be exactly one legend by composition. And why? Because the chart is going to create and destroy the legend because the legend is intrinsically part of the chart. So now we can see how we can pull out the different components of the design based on the problem definition, and each one of these components is going to map to an actual programming construct, in this case, classes. Okay, the next problem. A 3D flying game has three types of projectiles: a bullet, a dart, and a guided missile. Each has a position and a velocity. The bullet honors gravity, drops slightly with every frame, this gravity does, and the dart flies straight. The guided missile always turns towards the desired target, but blows up after 30 frames, and each renders differently, of course. So let's see here. I'm going to have a bullet, I'm going to have a dart, and I'm going to have a missile. But notice how there's so much similarity between these and I'm not really capturing the commonality. So I should really try something better. How about this? I'm going to have a projectile which has the position and velocity, and that's going to be common to both bullet, dart, and missile. Now, the bullet is going to have the drop due to gravity. The missile is going to have the time to live, so I can expire after 30 frames. But all of them are going to want to move and to fire and to draw. This is example 0.3.3, 0.3.4 in the Class Diagram 2 chapter of the Software Design textbook.